So hopefully you can respond on that. And after that, we also talk about the three types of software, okay, that is indicated from the research of Lemon, okay, S type, P type, and E type. Okay, so what is S type? S type stands for specific. Specific means that this type of software, okay, whether it can be accepted or not, actually must be based on the specification. Okay, means that the specification of this type of software should be very clear. Understand? Even though the solution formula is provided. However, for the P type of software, it may have a very clear specification. However, in terms of implementation, it may be not so practical. Maybe it's the complexity of the logic, or maybe it's other factors. And for the E type of software, this one is a bit special. Why? It's called an evolved type software, in which the specification may not be 100% complete. Understand? Okay? But this software will evolve, okay, rapidly based on its environment. Okay? Either it's a business environment or either it's a community. Okay? So, for example, this type evolved type software, E type, example, those business software you created, eventually operating system, invoicing, software. And for the S type software, okay, let's say for example, a calculator, okay, and E type, what we call E type software is like, let's say, a chess game, okay. So these are examples. And we also discussed about commercial off the shelf. Okay, what is commercial off the shelf? It's those component software items, okay, that we gain freely from third party, or we gain commercial, okay, we gain from buy and purchase or procure from other suppliers. So this is the commercial off the shelf. Now we need to continue with the following topic, CBS. CBS stands for component-based system or component-based software. Okay. So what I mean by CBS here, component-based, is that these are software they are built, okay, by integrate different components together to form a system. Okay. Okay. So the word component here actually is those software or software, okay, or software item that can be individually operate, but it also allow other components or entity to connect. Okay, so therefore those software that we build mostly by combining or integrating different components together, this is called as a component-based system or component-based software. Understand? Okay? Now, as you see that on the slide here, the description of component-based system. Okay, so what is the maintenance activity that mostly happen in the component-based system maintenance? Okay, because those components mostly is bought from the supplier. Normally, okay, we are not allowed to access to the source code of this component. Understand? Sometimes it's because maybe it's already hidden by the supplier. Sometimes it's maybe because of the copyright issue. Understand? So therefore, what kind of maintenance we can do in this one, in the CBS software, normally actually is more to, more to the area of integration only. Understand? More to the area of integration means we maintain the integration between the component. Maybe we integrate our system with a new system, okay. Maybe we perform the updates on the component so that it can integrate and so on. Okay. So maybe we can add new component or remove new component, upgrade the component, and so on. Okay. So mostly the activity of CBS maintenance will be more to the integration. Okay, so like add component, remove component, okay, update the component. You understand now? Okay, and maybe monitor the component performance and so on. So this is the common activities that we apply, okay, during the maintenance of CBS. Okay, so now you can see that, okay, CBS system is an interacting group of large-scale black box component. Okay, he emphasized on the word black box. Black box means that we cannot know inside what is happening on the component. Understand? Okay, and you can see that. Okay, so most of the source code, okay, in the component in order to deliver service actually is we implement the wrapper, glue, or tailoring modules. What is a wrapper, glue, or tailoring modules? What's mean by these three terms here? Wrapper, glue, and tailoring. What is a wrapper? When you read this word, wrapper, glue, or tailoring, can you perceive any idea by reading this word? Wrapper, what's a wrapper? Wrapper, let's say for example, okay, if I want to buy a present for my friend, okay, so normally I will use a piece of paper, okay, gift paper lah, okay, to wrap the item. Alright, so my friend can only see the surface of the gift paper, understand the pattern. He do not know what is inside, right? Okay. Similar concept. A wrapper actually is a layer of code, okay, that used to surround, okay, used to cover certain functions, methods, services, or even the component. Understand? Okay. So in this case, the external entity they connect to the wrapper to obtain the service of the component. Understand? But they cannot see anything. What is actually the inside looks like of the component. Understand? Okay? Anything is go through the layer of code which is called the wrapper. Glue is a code used to combine two different code together. Understand? Okay? You get me? It's to combine two different code together. Definitely need to modify the code. Okay, so okay. So tailoring is the process, okay, that we build a certain things by combining different units together. Let's say for example, you imagine that okay, my shirt is a system. Okay. So first, okay, I tailor my shirt with the sleeve here. Is it called sleeve? Yeah, my sleeve here. Okay. So combine together. Sleeve here, combine together. Okay. My collar, combine together. Okay. This is called tailoring. Understand? This is called tailoring. Maybe in the tailoring they may use glue, okay, whatever method. Okay, to integrate it. Understand? So this is the okay, so maintenance that may be used the wrapper, glue, and tailoring, okay, to integrate the component on the unit, okay, instead of they just okay deliver the service directly. Understand? This is a CBS CBS maintenance activity. Okay, so therefore I say that mostly is deal with the integration task. You understand? Okay, any question? So, continue. There is some difficulties that may face by the CBS maintenance. Frozen functionality. Why? Because let's say for example, Okay. Let's say, for example, where do I stop? Let's say, for example, okay, frozen functionality. When we buy the component is from the supplier, right? Okay. Then sometimes the supplier may close door already, shut down. Okay. Maybe run away the receipt. Okay. Maybe purchased by take over by another supplier. So the component is no longer supported. Alright. So in this case, they may not have the functions are okay. The support of the functions are you cannot find anyone to support it. Understand? Okay? Frozen functionalities. You get here. And then ourselves we can access to the code now because it's black box now. Okay, then come to work. You get here, okay? So incompatibility of upgrade, yes. Maybe this can be two sides lah. Okay. One thing is maybe our software need to upgrade already. But however, this component from the supplier they still remain in the existing version. When we upgrade, not able to compatible. Maybe the supplier upgrade come out with a new version of this component. But however, because of maybe certain factors such as the rules or laws okay, then you have to upgrade. Okay, no choice. Then however, when you upgrade component, then cannot integrate, not compatible with our system. Two reasons, either one way, okay. So, and then Trojan horse. You know what is Trojan horse? What's the Trojan horse? Some sort of like a track to the software system. Okay. So Trojan horse is some of the piece of the code that reside in your system. Okay. When the time is come here, then you will execute, am I right? Okay. Then you count the system, see the data, whatever. Okay. So some component may have this kind of Trojan horse. They purposely design. They want to steal your information. Okay. And unreliable COTS component, yes. Some component, even though you buy, import from or you procure from the supplier, those components cannot be so reliable. You cannot say it cannot work. It can work. Sometimes maybe the result may not be so stable. Okay. Defective middleware, yeah. You know it's a middleware, 2073. What is a middleware? Yes. Anyone? What is a middleware? Okay. Yes, 2073. What is a middleware? It's some sort of like middle type. Some sort of like a software, okay, or maybe just a piece of code, okay, that used to play in between two particular components or two particular services, or maybe in between your operating system and your system, okay. So to act as a agent, okay, to handle the request queue, data pass among the two different parties. Okay, one example is like your gateway, understand? The gateway, okay, certain APIs also can, let's say your broker, okay, it's also can be considered as a middleware. Okay, some middleware you use, okay, may not be so easy. Maybe there is some bugs, okay, or maybe there is some limitation, okay, so that when you integrate, yeah, you can integrate, but may not be so up to your expectation. You get it. Then maybe cannot run. Okay. Maybe you reduce the speed of your system, the performance speed. Okay. Maybe certain security flaws. You get it. Okay. So these are some of the difficulties in the component-based system. Okay. And activity. Some example of activity that we can that is happen, okay, during the maintenance of CBS. You can see that component reconfiguration, testing and debugging, monitoring of the system, enhanced functionality, configuration management. So you can see that, okay, first one, component reconfiguration. As I said, because we really cannot touch inside the component, okay, we are more into the integration. So component reconfiguration, like just now I said, remove a component, add a new component, okay, replace a component, okay, and this is all replaced, just that you replace with a newer version, or you replace with a better one, you replace with a commercial off the shelf components, like that lah, understand? Now class, bear in mind, components-based system, okay, not necessarily all the component is buy from the supplier one. Some component maybe is built by yourself, understand? Okay, bear in mind, okay. So this is one of the activity is the reconfiguration of CBS. Okay. Another activity, this activity not only happen in the CBS, it also happen in other maintenance, right? Testing and debugging. Okay. But however, in the testing is you are testing after you have integrate or replace a new component, okay. If the component is from the supplier, okay, then you need to test it whether the integration is successful or not. If the component is your in-house component developed by yourself one, okay, then is maybe you change the code inside the component, okay. Then you have to do a certain testing, regression test or others necessary testing to check for any fault or any bugs. Understand? Okay? And that's it lah. Now class must be very careful when come to this slide, modifying the source code to fix the defect. Look at the criteria here. In-house developed system. The component is developed by yourself. Then you can get the source code. For those COTS components, you cannot get the source code. Understand? Okay? Commonly okay. So, and next activity, definitely you need to monitor the performance of the system. Okay, so from time to time, check how is the system performance. Okay, is it the system has any tendency to fail? Okay, is there the system has any tendency to hang? Okay, and then how is the performance like that lah? Okay, and then measure the resources that consumed by the system. Okay, and maybe keep track any anomalies or maybe abnormal behavior of the system, okay, during a certain situation and so on. Okay, now enhance the functionality of the system. Functionality for user. Okay, maybe you can, for example, okay, add the new features to by adding another component. Okay, if your component is an in-house one, maybe you can add new features in the in-house component and so on. Okay. Okay, and also, when you want to combine the component or product together to provide more functionality, as just now we said, we may need to use the tailoring techniques or glue, okay, to do it. You can see that in the action of access to the source code, tailoring is done by means of two techniques. Write additional glue code to hold system together. Use vendor supply tailoring technique to customize the product because integration personnel have no access to the program code. Okay? This one is referred that when the component is not done by you, okay, then you may need to use the tailoring techniques to integrate it. Okay? Now the last one, configuration management. Yes. What is the configuration management? Actually, this one is in chapter 5. Configuration management is those activities, okay, we apply to our, not only to our software maintenance, during our software development also. Understand? Okay, that used to keep track, okay, the status of items, process, individual, okay, anything involved in your project development. Keep track, understand? So that he can provide traceability to all the item status, okay, and to reduce ambiguous, okay, enhance the quality. Understand? Let's say for example, versioning system. You know what's versioning system, huh? The GitHub, okay? The GitHub, okay? You can main branch, you can have many different branches now, okay? And then different versions based on how you use it, okay? So from there, you will know that, okay, which one is the newest one, which one has been published, which one has not been published, all right? So by using this kind of tools, then when you want to modify, definitely you are going to modify those one newest one or maybe current newest one, all right? Okay. Then in this case, by using this one, you will be confused. Okay, which one is the latest one? Which one is the existing one? Am I right? Then we will modify the wrong thing and implement the wrong modification. Okay? So reduce the ambiguity, okay? And allow us to track the changes. Version 1, 2, 3, 4. Okay? Ensure all the artifacts is updated. Get me? Okay? Provide traceability. This is configuration management. Okay? When I say all the items, the items inside software development, inclusive of software maintenance, what kind of items? You know, many items. Our software tools, okay, coding, documentations, report, test cases, during the software development, the process, okay, what is our process now? You get me? Okay, so we may have certain way to record it so that we can trace it. Okay, all those activities that perform, okay, for this purpose one, actually it belongs to configuration management. Understand? Okay. For example, your SRS. See SRS? Already home, sorry. Okay. Last semester, when you study software requirement engineering, each of the requirements you need to put a number there. Alright. So why you need to put a number? For what traceability, right? If you generate a test case, you want to show test cases is for which requirement, you have your test matrix, am I right? Okay, then you can put the number of, am I right? Okay, rather than you put the entire description name of the system requirement, right? So for what traceability? Test cases also got number one, am I right? For your document, each document you have your number. Every update of your document, changes of your document, then you should have another number to identify it. So all this activity is called configuration management. Okay. Not only applicable to the software maintenance, it's also applicable to the entire life cycle of software development. Okay. Okay. Come back to our slide here. Configuration management. According to the author, okay, there are two levels. One is applicable in the source code okay, for those in-house component, okay, you manage the source code. Okay, in-house component, you can manage the source code now. Then you have to, how to say, apply the level to keep track the status, okay. And component level, okay, for those third-party component. Let's say this component, you bought it from the supplier. Then configuration management, you need to have a record to record out this component is from which supplier. What date you buy it, okay? What is there any agreement? What are the agreement? Is there got agreement? Then link with the show the agreement number. Understand? What is the expiry date? What is the support date? Or everything keep track. And then another version come in, then you have another record to record it. Understand? For example, okay. So this is the two level. One is deal with those source code level, which is from our in-house component. Another one, COTS, you cannot do anything in the source code, right? So you have to record down whatever information according to this COTS law. Okay? And these are some examples, okay, of configuration management. Track version, okay, set the name of the developer of the component, okay, save the contact information, archive source code, archive the working version of all tools items that it involves. Understand? Okay, so this is example of maintenance activity for CBS. Another example of maintenance activity, trace the configuration history, okay, find compatible version, manage the license, manage license also configuration management. Let's say for example, you are a company, okay, definitely you are developing something, but you definitely got all those what? All those computer okay. Let's say for example, all your computer is Windows. You need to keep track, okay, how many license of Windows license that is it sufficient for your computer or not for the development, okay? Do you have the license or not? If there is any upgrade, how many computer is being upgraded to new OS? How many is still resumed? This one you need to keep track, and this is also configuration management activity, okay? And others, okay, obtain contact information, okay, still, okay, it's also. Okay, I finished already. Okay, any question, class? Any questions for the CBS maintenance? Any questions for CBS maintenance? No. Okay. No, then we may proceed to chapter 4. Okay, maintenance model. Maintenance model. Okay, are you ready? This is a very difficult answer. This question is, are you ready? Okay. So, yes. So, shall we proceed with the chapter 4? Okay. Chapter 4, okay, is regarding the maintenance process, according to different standard lah, and also the maintenance model, which is applicable or practiced by certain researcher or identified by certain researcher. Okay, so look at this diagram here. This diagram shows traditional software development life cycle stages, right? Isn't it? So as you can see that the number here, maintenance phase consumes the highest percentage of resources. Okay, inclusive cost, time, okay, I mean the phase, not the activity. Okay, so so therefore, this maintenance phase is a very special stages in the SDLC. Okay, why? Because he may include different type of activity. Okay, even those activity may not be happen in the previous development activity also. Understand? Okay, so you and then you can face a lot of different incident or issue during the software maintenance phase. So therefore, I said this one is a very special stages. Why he consumes so many resources? Not because of the different type, not only because of the different type of activity, because maintenance, remember the purpose is to ensure the system keep on working. Am I right? Okay, keep operating. So therefore, after the implementation of the system, imagine that, okay, how to say? Imagine that, okay, before the system is obsolete and it's not going to be used by the company. Okay, maintenance activity is still needed. Am I right? Okay, so means that maintenance state is a very long, it's a long life or long term activity. Okay, so therefore you can see that during this period, okay, the consumption of resources is very high one. Understand? Okay, now we come to some process of software maintenance according to different standards. Okay, the first standard is IEEE 1219. As when you look at this, class. Look at this one. Why I'm so excited? Look at this one. Take a note. Okay. That is okay. The word is here. Okay. Because last semester, no, last semester, last semester, okay, I don't know what happening. Some students they said that when they download or whatever in what form, okay, so some of them is missing, understand? So when I display here, got one, okay, so please take a note, understand? Okay, take a note, okay, so now for the IEEE 1219, okay, they say that the maintenance process, okay, this is the maintenance process. When there is a change request for maintenance, they start to analyze the problem, classify the problem, okay, or identify the problem. After that, okay, this problem is what is that called? It's a bug, okay, or maybe it's any other purpose or any other issue. Then they categorize it, okay. Then after that, they analyze the problem, okay, and design necessary solution and implement the solution, test the solution, okay, system test, okay. When after you implement, you perform a system test, okay, see whether is it any issue or not. And then acceptance test is for the user, okay, and then done already, we deliver the solution. Okay? If there any other request, then you follow the same cycle. You get me? Okay? And the next one, never mind, continue. Okay? So for each of the 7 activities, 1, 2, 3, 4, 5, 6, 7, there are 7 activities process here. Okay, so each of the activities, okay, may have these following 5 attributes. For example, the definition of the activity. Okay, what is this activity for? Okay, input of the activity, output of the activity, control, what is the control that you need to apply to monitor, okay, to monitor and to keep track, okay, the activity, the metrics you use to evaluate or to measure, okay, the activity, understand? Okay, to measure the items or to measure the performance of the activity. Okay, so these are the 5 attributes associated with each of the activity here. Understand? Okay. Let's say for example, okay, the input of this activity here, analysis stage here, okay, what's the input? Is the problem, am I right? Is the problem. Then what is the output of the analysis activity? This is maintenance, not software development. Okay, so what is the output? Can you guess what is the output of the analysis activity here? Maybe it's the cause of the problem, understand? Okay, and the affected area of the software. Understand? Maybe okay. Maybe the you say that okay, the cause of maybe function 1, okay, produce wrong output. Okay, so they analyze it. Okay, maybe there is certain code. Okay, or maybe there is a lack of efficient code whatever lah. Okay, maybe typo or logic error. Okay, then they will. This is one of the output from the analysis. Another one is maybe because it's the affected module. Understand? Why we need to know the affected module also? Because once we have provided the solution, we need to perform a regression test, am I right? What is a regression test? It's a test that to test implemented unit, okay, that is it will affect the other part of the software, right? Isn't it? So when you have those affected or related module or functions to this particular problem, then you have to test Am I right? Okay. So this is an example of input from the output of analysis, and this is maybe the input of the design. Am I right? You know the problem, then you start to design the solution, no? Okay. You understand? Okay. Then after that, the outcome of the design is the what? It's your solution design Am I right? It's the part, okay, that maybe what is the code structure or what is the new pseudocode or whatever thing. Understand? Then you implement it, this one as a input of the implementation activity. Then you do the coding, okay, construct based on the design. You construct the code. Am I right? Okay. Then after that is your come up with your working solution already, right? Then you integrate it. Then you have to test, Am I right? So from the system test here, okay, it can be any type of test, regression test, or maybe any other non-functional performance test or functional test, whatever okay. Then you perform it. So this is the input and output. Understand? Okay. And what type of metric, measure, and control? It depends on the problem. Am I right? Okay. So, for example, you want to monitor monitoring. Okay. So that is maybe that is a changes in the software, design changes, implementation changes. How are you going to monitor these changes? What is the procedure? What is the step? Understand? Okay. Who should be reported? What kind of procedure should be followed? Okay. Is there any tools to use to monitor it? Understand? And then you may need to use certain measure when, let's say for example, normally maybe measure, for example, not only to the solution. Let's say you have done the solution already. You want to know that the efficiency of your coding. Then you have a certain measure to measure it lah. Okay, depends on the solution lah. Okay, maybe this is just a logic error. Okay, then you should have maybe certain level of test to test whether the output is correct or not. No? Understand? Okay, and maybe you need to measure measure in order to evaluate the efficiency of your maintenance activity. Okay, then maybe you need to measure, let's say by time. Okay, by how many codes. Okay, how fast the maintenance can be done. Okay, so this is certain measure. Understand? Can okay. Hey, this one measure is in your SQAT one, right? Help desk. Still can recall help desk HD metric, isn't it?
Yes.
Right? Okay. Any question? Any questions? No? Okay, come to another. This is the process of another maintenance process by another standard. Actually, even though another standard, but however, those process is more or less the same. Maybe they use another name only. Okay, so ISO IEC 14764. You can see that. Okay, you need to know how the maintenance process, understand? Implementation on the maintenance procedure and the process first. Okay, because it's for the monitoring and the control of the maintenance. So when you perform maintenance, okay, what are your procedures you need to follow? Okay, what are the steps? You identify it, implement it. Then, if there is a problem there, same thing problem, analyze the problem. Okay, perform some impact analysis. Okay, impact analysis means that you want to know that okay, when I modify this part, okay, which part will be affected? Understand? Okay, so and you perform, implement the modification, implement your solution, and then test, review, and so on. Okay, it's a circle, and then you can see that done already, then accepted already. Migration. How are you going to implement your solution to take over those parts that need to change one? Okay, and retirement. How do you say that okay, the maintenance activity is finished and your task is finished already, and the new solution okay, can run already. Understand? Okay, so these are some steps you need to do it. Maybe you may have after inside here, maybe you can have a post-mortem. Okay, post-mortem meeting whatever Okay, so this is another standard that describes the maintenance process. But actually, overallly, it's almost the same. Understand? Okay, just that one is seven activity or 7 process. One is 1, 2, 3, 4, 5, 6 only. Understand? But here they combine. Am I right? Here they combine. The design here is they will have the design, but actually got already. Either is inside here. Okay. Now, you can see that process this is the further description on the process here Process implementation, problem modification, and so on. Process implementation, you need to identify, create the maintenance process, the step. Okay, as I said, Okay, then analyze the problem, confirm the issue, okay, and know what are the things should be modified by performing the impact analysis, and implement the modification, maintenance review, okay, conduct an evaluation, testing, whatever thing, okay, and then when you sure no issue already from the solution, then migration, as I say, implement the solution, okay, to the existing system. Okay, then in this case, you need to decide what kind of migration strategy you need to apply. This is just like your, when you study your software engineering, it's just like your what either you are going to use the what cut over have you ever hear about cut over, parallel run okay, also like that understand? Okay, migration, okay. Either you are going to carry out the process in parallel, inform the user, okay, the transfer, the migration has begun, conduct a post-op evaluation, like something like a post-mortem, okay, and make sure that the old data can be accessed, okay. So this is the migration activity. Retirement, develop a plan for retirement. So means that after you implement, okay, after a certain time, then you should confirm that okay, it's fully migrated already. That is the end of your this particular maintenance activity. Understand? Okay. So inform the user. Okay. And so on. Okay. Now, any question? Any question? Any questions, class? Okay, no questions. Then we take 5 minutes break. We will continue with the maintenance model. Okay. Is it time already?
Payment only company has some computer which all belong.
So therefore, if I just suggested to children because first I start the challenge you may face. Okay? If you want to use the PayPal, okay, the PayPal there is some sort of like study version one. API, PayPal. But that one is just like a study version, but not that you cannot really transfer the data. Just that to show you this PayPal is connected to PayPal. PayPal. But that one can use one. Basically, what they call the study version. Yeah. You may need to pay. I guess
So far, the raise the pay.
yeah, how you used to do the payment?
Can you give me
Is it the university title given to you?
学校外的和他跟我讲你的那考那个好吗？还有一次我那边
Tell the name you want to know. It's a platform to connect. And pay a certain fee for
You can, if you want to use the money one, you can use the pay education. Okay, but that one is only for PayPal. Okay, but for your one, okay, I don't know sure. Okay, but your selling point should be the program and how good is quite convenient to the trainer and user around that. I guess you better check also what is payment
Japanese fire base 在烧。那个是那个 steak， 我才弄掉。因为它是烤的。你要看什么？找不到。没看可以。哎呀，我什么女子？不写在纽扣，我跟你说。老师叫我放。哦。看到吗？早上我放给你。有一个粉焖，然后粉焖说我可能没去配的，所以，还有，你看他刚牙膏，那还可以放当用。我一起。
You find the airport API, airport API for what? Something like artificial version or what the heck? There's a website called sample. Yeah. What's the name? Brain tree. Brain tree. Because I use it in my web application.
You did not pay anything for it completely?
Yeah, okay. Totally free. Unless you switch it to the development part. You pay. This one is only like yeah. Not naturally. I guess it's for everybody example.
你们这个，这边这个，
我跟他讲这个星期六，然后他讲，OK， 然后我就说，
哦，你们的你有做可以吗？
没有吗？我是你不用赔分
哦，你是做过来
有把 S3 它有 support 它不同的那个 payment， 你可以特别来可以outcome，然后还有其他的。可以看看。
之前你看那个，现在又把你打掉，而且掉在那边。
然后现在讲就要一个地方。
大家手机跟我一样的身体。
也是做一个 application。有类似也是，就是因为需要到transaction前我们
因为我看到你们在这个老师做，
你穿一定是可以的。
还有 SSM 的套
黑豹，反正你看。
I am not rich like you lah, Singapore boy. 你是做完了？
啊，差不多。还没做。
吹完了哪个来个全部？
那个全部可以走。我用 Gemini 你们讲。我撞到。
我以为你用 GPT。
没有啦 ，GPT 我弄不到反正觉得那个 Gemini 更好。我是用 AVBM 的，用那个什么的 Model View Model 那种方法去写 code， 所以我就不用做一个 Activity UI 这样。好的，我直接用那个 coding code 就可以了。
太细了，太薄一薄。
什么东西？
这边有 provide coding code。
I guess we shall continue.
要自己做，自己我另外 API 嘛。
Okay, class, we shall continue with the rest of the topic. Are you ready? Am I ready? Yes. Okay, class, now we come to this topic of maintenance model. Okay, when we do models, okay, so some of the are you ready or am I ready? Yes. Okay. Go. Maintenance model. Okay. So now, for this topic here, okay, we are going to talk about reuse-oriented model. Reuse-oriented model means that, okay, normally when we want to maintain our system, okay, when we follow the reuse-oriented model, we try to reuse those existing item, okay, for our maintenance. Why want to reuse the existing item? Because save our effort. Okay, not every time we need to develop from the ground. Understand? Okay, we may find certain similar items that we can reuse. We modify a bit, then we implement it. Understand? So this is called reuse. When we practice in this way, we follow some sort of a model. We call the reuse-oriented model. Under this reuse-oriented model, there are three models we are going to discuss here. Okay, so class, look at this diagram here. This diagram is just provide us a common understanding on the reuse, okay, model. Okay, so it's a very common overall. Now you can see that I make it bigger. Okay, old system, new system. Okay, so requirement analysis, design, source code, test data. Okay, any item fall under these stages here. Okay, artifact, whatever things we can reuse, we modify it, and use in the as a new system. Understand? Okay, so this is the common idea of reuse-oriented model. Okay, any item, not necessary code, test cases, requirement, design template, okay, or everything that you analyze it, you make sure that it can reuse, then you can reuse it, modify a bit, and apply in the new system. Understand? Okay, so in this case, okay, you save us a lot of effort. You get me? Let's say for example the design pattern, okay, the architecture style in the design, the coding, test cases, okay, and so on. Okay, so this is the common concept, but definitely we not expected that everything we can directly reuse one. Definitely we need to do some modification. This modification is the transformation. Understand? Okay. Now, okay. So in the reuse-oriented models, okay, it assumes that existing component can be reused in software maintenance. Consists of the following steps: identify those components that can be reused in the old system, understand the component, modify the component, and integrate the component into a new one. if there is the component in the old system can be reused. Okay, this is the common idea of reuse-oriented models. Understand? Okay, this is a general topic. Under this topic, we are going to discuss the three reuse model that are fall under this reuse-oriented model. Okay, the first one is the quick fix model. Quick fix model means that you directly go and modify the existing code. Understand? Directly go and modify the existing source code and implement into your maintenance. Understand? Okay. So, but this way, that is in this model, they practice there are lack of concern on the effect of the modification. Understand? Because you direct modify the source code, okay? There are lack of concern on the effect or the impact of the modification. Understand? When you modify your source code, then by using this quick fix model, means that you are not so really detailed analyze the impact on the effect of your modification. Okay? So this is the quick fix model for maintenance. Okay? Definitely low cost because you directly go and modify the code so not much activity is going to be appeared here. Understand? Okay? So this is a commonly used approach for software maintenance. Okay? Now, another model is called iterative enhancement model. This is a very formal. We follow the Kaizen approach, development approach. Okay, so have you studied Kaizen development approach? Go and find the related topic on Kaizen. Okay, so it's quite a huge topic one. Okay, so this Kaizen topic actually he follow a formal way of developing, but here is maintenance okay, he also follow a formal way of step or phases in here. Okay, but in this model they are gradually change or modify the necessary part of the system. Understand? So gradually means that one part after another okay, incremental. So they will start with a requirement. Okay, what is the solution? What is the problem? What is the requirement? And then they go to design the solution. Okay, modify, coding, test, and analysis. Definitely, this one is from the existing component, understand, or existing artifact. Then after that, they may start again. Okay, gradually, okay, maybe and continue with another part gradually. Okay, and until settle. Understand? Okay. This is iterative enhancement model. Okay, so you can see that generally, okay, changes are from the high level, which is the high level document, means the analysis document, requirement document. Then they proceed down to the design and then to the coding, testing, and so on. Okay, and then after that, they gradually maybe they move forward to another part, okay, that need to for the changes or the maintenance. Understand? Basically there are 3 steps: analyze the software system, classify the request modification, implement of request modification. Okay. This one is another model called the full reuse model. This full reuse model is daily practice of the reuse. They have a repository, okay, like a store, like a database, okay, that consists of all those reuse items. Understand? Okay, all those reuse components, reuse item. Okay, then when they need it, they are going to search in the repository. Okay, see which item is suitable for this particular maintenance task. Okay, then they will reuse it but definitely there is a modification on that. Understand? So this is a full reuse model. Requirement, they check on the requirement repository. Any requirement can be reused. Reuse. design, coding, and test. That's it. Understand? So these are the three models of reuse under the reuse-oriented models. Understand? Okay? These two models, if you are interested, then you can do your own finding. Okay? So, any questions? Any questions, class? No questions, huh? Okay. This one, huh? Okay, we continue lah. Still a few slides only, only. Okay, now, are you still able to continue? Still got any available memory capacity? Got lah. Last row, is there any available memory capacity? Can Never mind lah, we finish this one lah. Just three stage model only, okay? Very fast one. Now we come to this stage model. This stage model is another topic. It's not the reuse-oriented model anymore, okay? So this stage model discuss the life cycle of a product. Okay, we can say it's a life cycle of an evolution of a product. Okay, now initial development. Okay, now you can see that the first stage model we are talking about is the closed source software. What is a closed source software? What is a closed source software? Private one. Okay, proprietary software. Okay, means that those software, the code normally have some belongs to certain parties one. Okay, you cannot simply go and steal the code use the code and so on. Okay, so this are software how is this stage model discuss the life cycle, okay, of the evolution, okay, of this software. You can see that initial development, okay, when they develop this system, they have the first version after the initial development. And then evolution, evolution means that there is a lot of changes, maintenance activity applied, okay, because when you study about the software evolution, right, so maybe it's the change of requirement, bugs, any issue, okay, and so on. Keep on changing, modify until when you come to the servicing stage, okay, then the maintenance or change activity wouldn't be so many already, okay. So in this case, maybe they just provide certain update patches or service patches only, understand, okay. So and then the software is still in the market, understand, it's still in the market until they come to this phase out, okay. So the software is starting to be retrieved from the market already. Means that this version of software starting not to be available, okay, for the new user, understand, okay. Then until the software close down, no more support, okay, no more support already, okay, bye bye, say bye bye, understand, okay. So this is the stage model for closed source software, understand. Imagine, you see this one is almost, imagine Windows, okay. Is this big stage model discuss some certain version of a Windows life cycle? Windows come out, XP version or Windows 11, okay. Then a lot of changes required, right? But we don't know lah. Microsoft know only, okay. The feedback from the user, okay. and then come to here servicing when after now because Windows 11 is still new, right? Isn't it? So maybe after 1 or 2 years, you can see that the Windows you may have only the service patches only, right? Then after another few years, you can see that there are some this Windows 11 is maybe is still in the market, but it's going to be like obsolete already. Then and after a new version come out, then Microsoft will announce until what date the Windows 11 will no longer support by Microsoft already, right? Okay, so no more sale. Okay, if you can get, maybe that one is an old stock understand? Okay, so stage model, understand? For the closed source software, okay, and there is another stage model. It's called the version stage model. This one actually is almost the same, just that this version stage model, it will show that okay, different version different version of software, they have the evolutions. Okay, you can see that after the first development version, evolve, service, phase out, close down. This is the just now the stage model we discussed now, right? And then now, even though that one is after the first version, then close down no more already, then they proceed with the second version. But this one, no, we discussed that, okay, even though the second version come out, the first version is still running, okay, until it's closed down, don't know when, but the second version is available. You get me? Okay, and then maybe the third version and fourth version, you understand? Okay, so this is another stage model to discuss the life cycle of evolution for closed source software. However, okay, what we can get from this stage model is there is no returning back. You can see that is from here to here, from here to here. You cannot return one. Understand? Okay, you cannot return one. Like your Windows, when you come to a certain level that okay is only updated, then he won't say that okay Windows 11, okay, then suddenly he come to support again and so on. Understand? Okay, he will not return one. You can see that won't return one. However, the last stage model discussed here, okay, is not for the closed source. It's for the open source. Open source stage model is a bit different. Free, rebel, open source model. Those open source, what I mean by open source? Open source that we can access the source code one. Okay? And free means freeware rebel also free one. Okay? Maybe those software you get from the public domain or free one. Okay? So the source code is open. Now, that is a slightly different. You can see the stage is almost the same. Okay? But however, you can see that is a dotted line. When after evolution, he come to the servicing, but he can go back to evolve again. Understand? He can go back to evolve again. And somehow you see that okay, when he come to the phase out, it's nearly want to like no people want to use already, but suddenly he will change again. Why? Because certain factors, maybe the certain developers, okay, they find that okay, this software, okay, can be used by them, okay, to generate a new one or create a new features for them to maybe benefit to the community or make money whatever okay. So they change the software, come to evolve again. Understand? Okay. Just like the first initial development, this may be the own in here development when you come up the first version initial version he may be the only version. It can be the only version without evolution one. Okay? Why? As remember, as our first class, I say for open source software, if I post a software myself develop, I post in the public domain. Okay? Maybe until 10 years after that, still no people want to use, even though no people look on the software. Am I right? Okay? The software may not be evolved. Understand? Okay? That is a possibility. Okay? If there is an evolution, then follow evolution by the user, by the people who use it, modify the code. Am I right? Okay? When we come to servicing patches, yeah, possible. But however, if there is any chances or any factors that lead to the evolution again, it will evolve. Understand? Okay? And this one same. Understand? So this is the difference between the stage model of open source software and the stage model of the closed source software. Understand? Okay? Okay, for the details of each stages, please refer to the notes. Understand? Okay? Please refer to the notes. Okay? Okay? So, any question, class? Any questions for the stage model? So fast, no more already. Okay? So, this is our chapter 4. Okay, so very fast, I continue. Chapter 2, chapter 3, chapter 4. Okay, now, okay, for chapter 5, okay, we shall continue next week. We shall continue next week, configuration management chapter. And your midterm will until this chapter.
Before this chapter.
Until this chapter. Include this. Okay.
Then finals from 6 onwards or 1 to 5 also will be here.
Final is from chapter 6 and onwards.
So midterm we have to I don't need to look anymore.
6, 7, 8, 9, 10, 11, 12. 13. Actually 12 and 13 is the same chapter. I just split it to 7 chapter. Okay. Understand? Okay, class. Any questions? Any questions, class? Okay. I guess now my okay. So no question then. Please make sure you set attendance. Then you may leave already. Okay.
这样它原本的你是直接按 Model Navigation 然后你拿掉它，
那我删掉了。
然后你就再开回。
再开这些后把这些，然后menu这边
一样啊。
这个一样，然后 navigation 它原本有给的嘛，也是要打底到完，然后再放自己的。你拉自己的，就这样按这个它这边你打了分，它也跳出来。
这个是 main 嘛 ，main 是还有一个那些 Model Navigation 那些。
我是放在 activity home 嘛。我main的话，我是一个进入那个 app 的那个是放空。
这也是跟着哪一个你 set 哪一个？
我是跟着了set给你，我set给你，刚好set给你。因为我这个我跟他 Viva 是做很大的，然后我想一下这个有去口发什么？
因为我觉得是那 fragment 的问题，因为我 fragment 我加你那个action bar 它是加它是有看到，只是它又加买那个 system 本身的 action bar，所以就有2个。
哦，不要2个。
可能也是因为我安排到。
我 可是 H 吗？不是应该你是拿掉那个天那边的？
拿掉是我拿掉哦，我自己要放新的。因为如果我都没有的话，它是直接 error，直接开不到那个。
哦什么来着？Fun Star，Home Star，Fun Star，Fun Star，Home Star。